Hi everyone, welcome back to Maths with Miss Murray. This is my 2026 Higher Tier Predicted Paper 3 walkthrough. If you haven't attempted the paper yet, then I would suggest pausing the video now and download it using the link in the description. I'm then going to go through every question step by step, and I will share the methods and exam techniques that I would use. I've put this together based on an analysis of the past 4 years of Edexcel Maths higher tier papers and topics that commonly come up that have not yet appeared, and also some topics that haven't appeared for a while. Obviously nothing is guaranteed, but this is my best guess at a predicted paper. So let's start with question number 1. And this is a Venn diagram question. Very common question to come up in the exam and has not yet appeared. So you have been given this set of numbers here, and they are even numbers between 1 and 31. So the first thing that I would do is to write down those numbers. So even numbers between 1 and 31. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on. And the reason that I'm doing this is because it's then easy to check that you've got all the numbers, because it's very easy in an exam when you're under pressure to miss things. So if you've got them all there, you can cross them out as you go, and make sure that you've got every single number in the diagram. So A is going to have this set of numbers here, and B is going to have this set of numbers here. So we've got to put those in the diagram. What I would always start with is this middle section, and that's the intersection or the crossover. Can also be shown with this symbol here. That's the middle section of the diagram. So let's have a look at what I've got in both. So if you look here, you have got an 8 that is in both. So I'm going to cross out both those 8s, and I'm going to cross out 8 in my list up here, and I'm going to put it in the middle. And then I've got a pair of 18s, so I'm going to cross them out there, I'm going to cross it out up here, and I'm going to put it in the middle. Then I've got a pair of 22s, and I've got a 22 up here, so I'm going to cross those out and put it in the middle. So there's 3 numbers that are common to both, there are no more. So anything else that I have got left over here, I'm going to now put in the circles. So in A, I've got 2, 4, 2, 4, 14 and 28. So I'm going to cross those out and put them in the circle. 2, 4, 14 and 28. And then I've got 10, 16 and 30 that I'm going to put in B. 10, 16 and 30 that I'm going to put in B. 10, 16 and 30. Now you'll see that I've got numbers that I haven't crossed out. That means they're neither in A or B, which means they go in the outer part of the diagram. So I've got 6. They can go anywhere, it doesn't really matter where you put them as long as they're there. 12, 20, 24 and 26. Okay, so the last thing I would definitely do, as I said, you can make mistakes easily in the exam, is just double check and count how many numbers you've got. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 even numbers if you count there between 1 and 31. And you get a mark for each area or each region of the diagram correct. That's what it's worth for. So if the middle's correct, that's a mark. If the rest of A is correct, that's a mark. Rest of B is correct. And if the outside is correct, that's a mark. So you can check your answers against which regions you've got correct, so you can work out how many marks that you've got there. So that is part A. So now it says a number is chosen at random from the universal set. That means this whole diagram. So you're taking a number at random from the whole diagram here. Okay, so it's out of all of those possible numbers. It says, what is the probability? So that must be written as a decimal percentage or fraction. It's always easiest to go with fraction. It must not be a ratio. And because we know it's out of the universal set, it's going to be out of 15. That's a mark already just for getting the denominator correct, because it's out of all of these 15 numbers. What is the probability that it is in A union B, or A and B? Sorry, not and, A, that means or. So this is or. Okay, this is and up here. The intersection is and. It means it's in both. It can be in either. It can be in A or B. And what I tend to think of is that as a unite. You unite, you combine everything in A with everything in B. You combine, you unite all of those. So if we count those, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 out of 15, and that's my second mark for having the numerator correct. You don't need to simplify here. You can, of course, put it in your calculator and simplify if you want to, but you don't have to. And you still get full marks. If you have simplified and given 2/3, that is still both marks there, but you don't need to unless it asks you to. So that is question 1 for 6 marks. On to question 2. Zoe wants to buy 6 tins of beans for the cheapest possible price. Shop A and Shop B both have a special offer, and you can see that because it's shown here below. So Shop A is 5% off the normal price of 48p. Shop B is 65p each, but if you buy 2, you get 1 free. So which shop should Zoe buy the beans from? So this is a comparison question. This is important. You must show how you get your answer. So if you just write an answer with no working out, you won't get any marks at all. So because I'm going to compare, I'm going to draw a line and I'm going to put A here and B here. So let's start with A. So I'm going to get 5% off the normal price of 48p. So on your calculator, I did show this on my calculator tricks video, but if you've not watched it, it's worth having a look at that because some of those things haven't come up yet. So I need to work out 5% of 48p, or I need to work out 48 reduced by 5%. So I'm going to show you 2 ways to do that. So you could do 5% of 48, and then once you've got your answer, you can do 48 minus whatever your answer is for that. And you can use your answer button on your calculator for that, and that will give you the answer. The other way of doing this question, because you're going to get 5% off, the normal price that you start with is always 100%. And if you're going to get 5% off, you're going to be left with 95%. So the other way you could do this question is to find 95% of 48, because that will take the 5% off for you all in one go without you having to do 2 separate calculations. So they're the 2 ways of doing it. I'm going to need to use my calculator for this. So I've got my calculator screen here. So if you remember, if you've watched my calculator tricks video, I need my percentage button. I'm going to do this method here, 95% of 48, because it's just one calculation. So I'm going to type in 95, and the percentage button is where this book is. It's called Catalogue, and it's actually under probability. It's a bit of a strange place on this calculator. So I want for 95% of, and of in maths means multiply. So that works with fractions of amounts, anything like that. Of is multiply. So 95% of 48 is, and it gives me a fraction. Because I'm working with money, I don't want a fraction, so I'm going to click my format button and I'm going to go down to decimal, and that will convert it to a decimal for me. So my answer is 45.6 pence. But that is just for 1 tin of beans. Okay, so the key information here is she's buying 6 tins of beans. So I've got 1 tin of beans is 45.6p, but because I want 6 tins of beans, I'm then going to have to multiply my answer here by 6. And then that will give you the total cost. I'm just going to show you, you can use your answer button. Look, so I can either do, I can just put in here times, sorry about that, times, and it's answer. That's my previous answer. Or you can use the actual answer button, which is here. If you've cleared it, it will put your previous answer in. So 45.6 times by 6 to give me the cost of 6 tins. And again, it's given me a fraction, and I want a decimal, so it's going to be 200, you'll have a bit more space on your paper than I've got here. 273.6 pence is the total cost for A. Okay, so let's have a look at B. 65p each, but I buy 2 and I get 1 free. So I need to buy 6. 1, 2, 3, 4, 5, 6. So if I buy 2, I'm not going to pay for that one. I buy another 2, I'm not going to pay for that one. So it means I am going to pay for 4 tins only, because every 2 I get 1 free. So I need to do 4 lots of, nice and easy, 4 lots of 65p. And you've got a calculator, so even if you think, yeah, that's easy, I know how to do that, the common mistake I see all the time is people doing simple calculations, getting stressed in an exam, making silly mistakes and losing easy mark. It's so easy to check on your calculator, even the simple stuff, so make sure you do that. So that's going to be 260 pence. So we can see here that it's cheaper to buy from shop B. So you get a mark for working out A, you'd get a mark for working out B, so that would be 2 marks. Your third mark here is a communication mark. It's a C1 or a communication mark. So you can't just circle B or put an arrow to B. You need to say which shop shall we buy the beans from. You can just say shop B. But you wouldn't get the mark for this on its own. You'd need to have shop B with both of these amounts being correct to get 3 marks there. Or you can write she should buy from shop B. But shop B is enough because you have communicated your answer there. So that is question 2 for 3 marks. Moving on to question 3. Now this is a transformation question that has been on the paper for every year. In fact, in my 18 years of teaching, I can't ever remember not seeing a transformation question somewhere on a paper, and it hasn't come up on 1 or 2. Sometimes there might be 2 different questions. I did go through in my paper 2 walkthrough the 4 different transformations, but I'm just going to write them again down here. I won't go through each one in detail. If you want to have a look at that, it's on my paper 2 walkthrough, my predicted paper 2. So reflection, enlargement, rotation and translation. They are the 4 transformations. The key here, it says describe the single transformation. So you only talk about one of these. And if you start muddling them up, then you lose all your marks. So only write down what you actually know. Don't start waffling, and then sometimes people will lose marks because they'll say it's been moved and then it's been turned. But then you've combined 2 different transformations there. So let's have a look at this. I can see here, does this look, let's look at a reflection. Does this look like a mirror image? Yes, it does. So it could be that one. Let's just check the others. Enlargement, has it been made bigger or smaller? No, it hasn't. So it's not an enlargement. Rotation, it could have been turned. Sometimes you can have more than one answer. So you could try, possibly could be a rotation. Translation means it's been moved, but it hasn't changed its orientation. So it hasn't been, so that's the opposite way around. So it can't be a translation. So, but this one, I'm going to go with reflection because I can see quite easily that this is a mirror image here, but it could possibly be a rotation as well. You'd have to try that with tracing paper. So with a reflection, you get 1 mark, because this is a 2-mark question, for saying reflection. So if you don't know what the other mark is for, leave it there because you're going to get 1 out of 2. The other mark is for the line of reflection. Now I would suggest drawing that in. Now you can see there's 2 squares here between these 2 points, and there's 4 squares here between the 2 points. So the point that is common in the middle is going to be, let me just get rid of those lines, is going to be here. Now I would draw the line of reflection in. So that is my line of reflection there, and that helps me. So when you've got lines of reflection, there will either be x equals or y equals. It wants the equation. Sometimes they'll allow y-axis and x-axis, but normally they won't give you the mark unless you've got the equation. This is where people often go wrong. If your lines are vertical, I always get that the wrong way around. If they are vertical, they're going to be x equals, okay, because they cross the x-axis. Yes, they're in line with the y-axis. That doesn't make them y equals. They cross the x-axis, and it's referring to the x coordinates being a particular value. So if we look at the coordinates on this line, this is -1, 0. -1, 1, -1, 2, -1, 3. So it's the x value that is always equal to -1, which is why it's x equals -1. So I said it again, vertical lines are going this way right down are always x equals, and if they're going this way, they will always be y equals. So the x-axis is actually y equals 0, and the y-axis is x equals 0. Often confuses people, that one. So all I need to say here is reflection, and you can say in the line, or you can just put x equals -1. That is enough to show that you have the second mark for your line of reflection. So that is the only two things you need to write here. If you write anything else to do with any of these other transformations here, you're going to lose both of those marks there because it says single. You can't muddle them up. So that is question 3. That is question 3 for 2 marks. Question 4 is asking you to simplify with algebra. This requires you to know your laws of indices. Again, very common questions to come up on exam papers. So the rules that you need to know are, if you have the bases the same, that means they're the same letter or the same number, and you're multiplying, then you're going to add your powers together. So when you're multiplying and the base is the same, you add your powers. This is essentially what this is telling you. A and A is the same, N and M are 2 different numbers, you add them together and you get your answer. If you're dividing, which I would write like this, if you're dividing and the bases are the same, then you subtract your powers. And then lastly, if you have a bracket, then you've got like this, then you multiply your powers. That only applies to the powers though, not to the actual numbers themselves, but we'll have a look at that in a minute. So these are my 3 rules that I'm going to need to use here. So first one, nice and easy. I've got to simplify p cubed times p5. Well, they're the same letter, so I can just add 3 and 5 together, and I get p to the power of 8. Next one, I have got a bracket. Now, this rule here is going to apply. So I can times the powers here for b. However, if you just do that, people often forget about 4a and leave those as they are, and that would not be correct. So if I've got something cubed, it's going to be 4ab squared times 4ab squared times 4ab squared. Cubed means times by itself 3 times. So what you're actually going to have to do is 4 times 4 times 4, which is 4 cubed. So you don't times the 4 by 3, you have to do 4 cubed, which is, again, I would use your calculator to check that, but it is 64. Okay, and then this is often one people forget, miss out as well. You've got a times a times a. Some people often leave the a as it is, but you've got to cube the a as well, so that's a cubed. And then b squared times b squared times b squared is going to be, well, we know 2 times 3 is 6, or 2 add 2 add 2 is also 6. You can use either the multiplication rule there or the bracket rule, and you get b6. So there's 2 marks there. So you get, if you've got at least 2 parts correct, you get 1 mark. So if you'd missed the 64 and you had this bit, you'd get 1. Or if you'd missed the a but you had the 64 and the b to the power 6, you'd get 1. But you get 2 marks for having it fully correct, and it's really common that people lose marks on questions like that. Okay, part C, this is divide, so I'm dividing here, and I'm going to divide each part separately. So I'm going to look at the numbers first. I'm going to do 16 divided by 4, which is 4, and again, check it on your calculator. Then I've got m to the power of 7 divided by m to the power of 3. So the division rule is I subtract my powers, so 7 take away 3 gives me m to the power of 4. That doesn't look a very good 4 there. M to the power of 4. Nope, not very good 4 again. Let's try one more time. M to the power of 4. Good. And then I've got to do n cubed divided by n, another one that people often make mistakes on. And it's these easy marks you don't want to be losing, especially if you're aiming for those higher grades. These are the ones you want to make sure you're guaranteeing. People often write that as n cubed, but it's n cubed divided by n, which is n to the power of 1. So 3 subtract 1 is n squared. Okay, just remember, if you've got an n on its own, it's the same as having to the power of 1. And the marks for this one are similar to the one above. You have to have at least 2 parts correct to get 1 mark. Both parts correct and you get 2 marks. So that is question 4 for 5 marks. So moving on to question 5, the diagram shows a rectangle and a triangle, where we can see that from the diagram. The perimeter of the rectangle is equal to the perimeter of the triangle. So that's the information I'm given, and I need to find the value of x. When you have a question like this and you're having to find a missing value, you have to make an equation. Very common. Forming equations is a very common topic. So the first thing I would do is use the first bit of information I've been given, and I need the perimeter of the rectangle. So I'm going to do that algebraically and write an expression. What people often forget is you've also got x minus 5 over here and 2x plus 7 over here, because perimeter is all the way around. So I'm going to show my working out in full. I'm starting with x minus 5. So I've got x minus 5, add perimeter, you add the sides together. 2x adds 7, add x minus 5, add 2x plus 7. So I would show your working out in full, because that gets you a mark even if you simplify incorrectly. Okay, so having an expression correctly written out for either of your shapes gives you 1 mark, but if you simplify incorrectly you're going to lose that mark, so it's worth having your working out written in full. So I have got x here, I've got 2x here, I've got x here, and I've got 2x here, so that gives me 6x. Then I've got negative 5, add 7, take 5, or negative 5, add 7. So I would check that on a calculator. I know it seems silly, but don't forget you make silly mistakes when you are under pressure. So 7 add 7 is 14, and then we're subtracting 10, so that gives me plus 4. So that's my expression for the perimeter of the rectangle. Now I'm going to do the perimeter of the triangle. So I've got x, add 2x add 11, add 2x. So I'm going to add those together. So I've got x, I've got 2x, and I've got 2x, which is 5x, and then I've just got plus 11. So having either of these correct or the expression unsimplified correct would get you your first mark. We now need to make an equation because we're being asked to find the value of x. Well, I've been told that the perimeters are equal to each other. So nice and easy. The perimeter of the rectangle is equal to the perimeter of the triangle. So that's exactly how I write it. Equal sign means they are equal. So that will get me another mark up to there. So 1 mark from here, 1 mark here. And now I have to solve it to get my last mark and find the value of x. So I've got x's on both sides. So I'm going to get rid of the smallest x. I'm going to subtract 5x from here. If I subtract it from the left, I also subtract it from the right. 6x take away 5x is just x. I've still got my plus 4. 5x take 5x is nothing, which is what I wanted. I wanted to get rid of it, and then I've got my 11 left over here. So now to get x on its own, I'm just going to subtract the 4. So that leaves me with x equals, and I would even go as far to say, do 11 take 4 on your calculator. I know it sounds silly, but you've got it there, so you might as well use it. 11 take away 4 is 7, but just make sure you check silly things like that, especially if you've got time at the end. Go back and check all your calculations. So that would give me 3 marks for finding out that x is 7. So that is question 5 for 3 marks. Question 6. So the diagram shows the plan, front elevation and side elevation of a solid shape. Now this hasn't been on the paper for a while, which is why I put it on there, because they do often bring back things that haven't been on there for a while. And people often struggle with this one, which is why I chose to do a sketch, a diagram here, because this is one that often people get wrong if it comes up. So a plan is a view from the above. Imagine you're in a plane looking down from the sky downwards. That's a plan. Front is what you would look if you were looking at it front on, what would you see, and side, if you were looking at it from its side on, what would you see. So that's showing me all my elevations there. So you might be given a 3D diagram and asked to draw the plan, front elevation or side elevation, but this one we've been given those and we've been asked to actually draw a sketch. I've written over the writing there, but I've been asked to draw a sketch of the shape, so, and give the dimensions. So I know it's a sketch, so you don't have to, when it's a sketch, it means it doesn't have to be drawn accurately. So this doesn't have to be 4 centimetres long, etc. But I would still use a ruler and a pencil. I'm not going to on here because it's quite tricky and it takes a while. But if you're on your exam, definitely use a pencil and a ruler if you can. So whenever you're doing a sketch of a shape from the the plan, front elevation and side elevation, always start with the front because it's easy to draw in 3D once you've got the front. So I'm going to draw the front out here. So that's my front part of my shape. And then I'm going to put the dimensions on. I'm told this is a centimetre grid, so that's going to be 4 centimetres along there. So I'm going to put 4 centimetres on here, and this along the top here is 2 centimetres. So I'm going to put 2 centimetres there. And then let's do the height as well because it's 3D, so you want the height. That's going to also be 2 centimetres. Now when you're drawing in 3D, the easiest way to do this is why I said to use a ruler, is you draw lines coming off diagonally off the shape. And you want to make sure that they are the same length. That's where your ruler comes in handy. So I'm going to go like that. That's my first diagonal line. Now my next one's going to come from this corner. I want it to be parallel to that one, and I want it to be the same length. So if you've got your ruler, you can do that. You can draw that line there. Actually, that's pretty good without a ruler, I think. Anyway, and then this one again has to match this one. It wants to be parallel, so you want to make sure that they're parallel to each other, and it needs to be the same length. Okay, so once you've drawn those, you then mirror the lines on the shape here. So this one's straight, so it's going to be straight at the back there. This one is diagonal, so it's going to be diagonal at the back there. So they need to be parallel to each other as well, and they need to mirror the same direction. So that is my 3D shape. I just need to put this distance here on. So if I look at my side elevation, it goes back 3 because this comes off of this here. So that will be the length there. And if you look at the plan, that's the front. So it goes 3 back. So this is going to be 3 centimetres here. So you get a mark for the sketch being correct, and then a mark if you've got all the dimensions on there correctly. But always start with the front elevation, draw that out, and then draw your parallel lines, and then match them up at the back there. That's the easiest way to do that one. So that is question 6 for 2 marks. So now we are on to question 7. In 2003, Jerry bought a house. Lucky Jerry. In 2007, Jerry sold the house to Mia and he made a profit of 20%. In 2012, Mia sold the house for $162,000 and she made a loss of 10%. So we know the price of the house now in 2012, and we've been asked to work out how much Jerry paid for the house in 2003. So we've got to work backwards twice. So this is reverse percentages. Again, very common. It was on both my paper walkthroughs, but it's not come up yet. So here it is again. I would do it slightly differently to how I've shown you on the other walkthroughs with the box. You can still use that method if you like that, but when you've got a calculator I would do it slightly differently. So let's start with, I would have had a house. Jerry bought a house. It would have been X. We don't know how much it was, and then he sold the house to me and he made a profit of 20%. So that means I need to increase the price of the house by 20%. So it would have started, here is my original amount, the 100% amount, what it was originally. If it's gone up by 20%, I want to know what 120% of the original value is. So I would have times that by 120%, because that will increase it by 20% for you and add it on, and then you would have got your answer here. Okay, we don't know what that is at the moment. So then I would have taken that answer here because that is how much the house is worth. He then sold the house. Mia then sold the house for $162,000 and she made a loss of 10%. So whatever the house was worth, it went down by 10%. So whatever this value was here, if this is now my 100% value, and it's gone down by 10%, 100% minus 10% is 90%. So whatever this value is, I want 90% of that. And that would have given me my 162,000 that I've ended up with. So when she sold it for 162,000, that was decreased by 10%, a loss of 10%. So I've got to work backwards twice here. So if we're working backwards and I want to find out what it was when Mia had it from Jerry, I'm going to, instead of timesing by 90%, I'm going to do 162,000. I've put that there, divided by 90%. So that's going to give me, and again, you can use your percentage button on your calculator. So 162,000 divided by 90, and my percentage button is under catalogue, remember, under probability, and then I've got percentage there, and that is going to give me, that's how much she got the house for from Jerry. So she got it for 180,000. So now we need to work out what Jerry bought it for. So that's this answer here, and this answer here is 180,000. So I've got to work backwards. So I'm going to now do 180,000 divided by, instead of times by, 120%. You might be used to using 0.9 or 1.2. That is the same because decimals and percentages are equivalents of each other. So I'm going to do that on the calculator as well. So I'm going to do 180,000 divided by 120, or 1.2 if you want to use a decimal, but I'm going to do 120% just to remind you where the percent button is, and that is 150,000. And if you want to check your answer, you can increase that by 20% and then increase the amount that you get, decrease the amount you get, by 10%, and you'll end up with the 162,000. So that is my working there, and then the house, he bought it for £150,000, and that is worth 3 marks. So you would have got a mark here for the first step, a mark for this calculation here, and then a mark for having the answer correct. So that is question 7 for 3 marks. Okay, on to question 8, and we have a density mass volume question. Centimetres cubed tells me that that's a volume question. That has been on the paper every year for the past 4 years, and it hasn't come up yet. They have had a pressure force area question, but I'm still convinced you're going to get a question like this. I may be wrong. We shall see. So liquid A has a density of 1.2 grams per centimetre cubed. 150, so that's my density there for liquid A. 150 centimetres cubed of liquid A, so the volume of liquid A is given, is mixed with liquid B, some of liquid B, we don't know how much, so we don't know the volume of liquid B, to make liquid C. Liquid C has a mass of 210 grams, so we've got the mass there, and a density of 1.12 grams per centimetre cubed. So we've got the density there, and we've got to find the density of liquid B. Quite a lot of information there. So with a question like this, I would set your working out in a table. So let's see what we've got. So you've got mass, you've got density, and you've got volume. They're your 3 things. Okay, and you need to have 2 of them to find the third. So that's going to go in my table. And then I've got liquid A, I've got liquid B, and I've got liquid C. So it helps to visually represent your information like this, because you can see what information that you've already got. So let's do it bit by bit. Liquid A has a density of 1.2 grams. So we know that is 1.2 grams per centimetre cubed. You can just put 1.2 if you want to in there. 150 centimetres cubed of liquid A. So we know the volume of liquid A is 150 centimetres cubed, is mixed with some of liquid B, so I don't know the volume of liquid B, to make liquid C. Liquid C, we know, has a mass of 210 grams and a density of 1.112 grams per centimetre cubed. Find the density of liquid B. Now, what a lot of people would be tempted to do here is just do liquid C's density, subtract liquid A's density to get liquid B's density. You can't do that because density doesn't work like that. And it wouldn't be that simple, would it really, if you think about it, for 3 marks. So you need to work with each liquid independently. So here I am missing the mass of liquid A. That's the first thing that I notice in each column. So this is what I would work out first. Now this is what you're going to need for this question. You are going to need the mass density volume triangle. They do not give you this. And listen to me when I say, if you forget this, you are a massive div. Of course, I don't mean that, but hopefully it will help you remember it. M is at the top, massive, div, D-I-V, see? M, D-I-V. So people often get that muddled up because the distance, speed, time triangle, distance is at the top. But that's the triangle you're going to need. So if I am doing the mass of A, that tells me I'm doing the density multiplied by the volume. Because if I cover up the mass, I'm doing density times volume. So I'm going to do that over here. So I know the density of A is 1.2 and I know the volume of A is 150. So I've got my calculator open here. So I'm going to do 1.2 times by 150. And then I'm going to get my answer, and it's given me 180. So I now know the mass of A is 180 grams. Now here with mass, because you know mass is a weight, so to get the mass of B, you can just do 210 subtract 180. You can't do that with density because it's about concentration of a liquid. So I'm going to do 210 grams minus 180 grams, and that will give me the mass of B. So that is 30 grams. But again, check it on your calculator. I know I'm not doing that, but you should be doing that in your exam. So that is 30 grams. I'm gradually going through and filling in the information that I have here. So now if I look down at column C, I can work out the volume of C because I have its mass and its density. So if I'm doing volume, that tells me I'm doing mass over density, which means divided. So I'm going to do mass of liquid C, which is 210, divided by its density, which is 1.12, and that is going to give me the volume of liquid C. So I can use my fraction button here. So I'm going to do 210, and then I'm going to divide that by 1.12. And that's going to give me a fraction. All my other answers are decimals, so let's work in decimals. And that is 187.5, 187.5 centimetres cubed. So I'm gradually getting there. So with volume, again, you can subtract one from the other to find the volume, because that's just how much, the amount of liquid. The only one you can't do that with is density. So remember that for your exam. So I'm just going to write that answer. Sorry, I didn't put that over here as well. So I can now work out the volume of B, because I have the volume of A and the volume of C, the amount of both of those. So I'm now going to do 187.5 minus 150, and again check it on your calculator, but that is 37.5. So 37.5 grams is the volume of B. So now I can work out what my question is asking me to, and that's the density of liquid B, because I now have the mass and the volume. So I can now go ahead and work out its density. So density, last one, I haven't done this one yet. If I'm doing density, I'm now doing mass divided by volume. So I'm running out of space here. You'll have a bit more space on your paper. I'm going to do the mass of B, which is divided by the volume of B. So that's 30 grams divided by its volume, which is 37.5. I put grams there, sorry guys, that's centimetres cubed. See, we all make silly mistakes. So I am going to do 30, and I'm going to use the fraction, so I make sure I do my division the right way around, because that's another thing that people often do, and they divide the wrong way around. If you keep it in the same format as your triangle up here and you write it like that in your fraction, you're not going to get your division the wrong way round. 37.5, and I've got 4/5, which you might know is 0.8, but there it is. Use your calculator. 0.8. So 0.8. I haven't got enough room to put the units, but it doesn't matter because the units are already there on my answer line. Okay, sometimes it'd be worth more than 3 marks, but it's very common for a question like this and people get really overwhelmed with that amount of information. So get your table down, work out what you've got and work backwards from there. So that is question 8 for 3 marks. So now we are on to question 9, a simultaneous equation. Again, very common topic on exam papers. Could be simultaneous equations with a linear and a quadratic. However, we've had quite a few quadratics come up already. Paper 2, and you had the quadratic inequality on paper 1, which is why I'm thinking they might put a linear simultaneous equation in. But again, I could be wrong. So anyway, simultaneous equations, it means the value of x here and here are the same and the value of y here and here are the same. So the idea is you want to get either the x's or the y's the same so that you can eliminate one of those variables. You can get rid of x or get rid of y, so you can solve that first. So my tip for you on simultaneous equations, because where people go wrong is the signs. When you're having to subtract with negatives, even with a calculator, you would be surprised. So if you've got 2 that are different signs, so I've got a positive 5y and a negative 2y, they're the 2 that I would look to make the same. Even though it might seem easier, I can just times this 3x by 2 to make it 6x. My advice to you is always, if you've got 2 different signs, go there, because you're then going to have to add your 2 equations, and it's easier to add than it is to subtract. You're less likely to make mistakes. But I can do it both ways if you like. So if I want to make these 2 the same, I need to make them both 10y. So to make 5y 10y, I have to multiply this top equation by 2, and to make 2y 10y, I have to multiply this bottom equation by 5. So it's not like a 5, it looks like a 6. So 5. I've got to do the same to the whole equation. Another mistake people often make, they think, especially this number at the end, you have to times everything. People always forget for some reason to times the number at the end. So if I times this whole top equation by 2, 2 lots of 6x is 12x. 2 lots of 5y is 10y. And 2 lots of 4.5 is 9. I've got my calculator open here in case I need to use it, because I noticed I had a decimal. And then the next one, I've got to times the whole of this bottom equation here, the whole thing, by 5. So 5 lots of 3x is 15x. 5 lots of negative 2y is negative 10y. So the y's are now the same number. They don't have to have the same sign. And 5 lots of 9 is 45. Again, all of these simple calculations, check them on your calculator when you've got it there. So now that these are the same value in terms of their number, not their sign, if you've got different signs here, in order to get rid of it, I need to add, and it's all, like I said, it's always easier to add, because negative 10y, add 10y is 0, it gets rid of it. Okay, whereas if the signs are the same, so if you've got 2 positives, you have to subtract them to eliminate. Same with 2 negatives, you have to subtract them to eliminate. So just remember, go for the opposite signs if you can. So I'm going to add my 2 equations together. So 12x add 15x. You can use your calculator to do 12 add 15, but that is going to be 27x. And that's now been eliminated because negative 10 add 10 is 0. And then 9 add 45 is going to give me 54. So I now need to work out x. So 27 times x is 54. So I divide by 27 and just use your calculator. You've got it there. 54 divided by 27 is going to give me 2. And there it is. But just double check everything on your calculator. So I've got x equals 2. So that would get me a mark there for working out that x is 2. Your next mark is the substitution mark. Even if the rest of it's wrong, you get the mark here for just substituting this value here into one of your equations. And again, I would always pick the one that's positive. If they're both positive, go with the one with the lowest numbers. It shouldn't really matter because you've got your calculator to check your answers. So where it says 6x, I'm going to swap my x for 2. I now know that x is 2, so I've substituted that in. That normally gets me my second mark. Even though there's quite a bit of working out still to go, that normally gets your second mark for the substitution. And your last mark is for having both answers correct. So 6 times 2 is 12, add 5y equals 4.5. I've got to solve this equation now to work out what y is. So I'm going to subtract the 12 from both sides, which leaves me with 5y equals, and 4.5. Again, look, you've got your calculator here. So 4.5 subtract 12 equals, and then it's given me a fraction, so I'm going to get, it gives me negative 7.5. So this is where your calculator comes in handy. So to get y, I have to divide by 5. So y equals whatever negative 7.5 divided by 5 is. So I can just pop that in my calculator, and it gives me negative 3/2. I would actually leave that as a fraction because it's going to give you a recurring decimal otherwise. Fractional answers are perfectly fine. They're equivalent answers. So you can give your answer as a fraction or as a decimal. So then I just pop those on my answer line, 2 and negative 3/2. And if I've got both of those correct, that is where my third mark comes from. If you want to see it done with me changing the x's, let me know and I can record that as well, but we'll leave it there for now, and that is 3 marks for question 9. Moving on to question 10. So we have been asked to work out the size of angle BAD. Oh, this looks bad. So BAD, we go BAD, and the angle is always the letter in the middle. So this here is the angle that I'm looking to find. So I'm just going to get rid of that, but just so you know, that is the angle there, this angle here. Give your answer to 1 decimal place. So that tells me I'm going to be using my calculator here. Now, because I've got a trapezium here, it might be easier to split your shape across the middle. So if you see that you've got a compound shape, which is 2 shapes, you can always split your diagram up. So now I have a right angled triangle here at the top. So you should know that this is 90 degrees here. So I've already got this is 90. I just need this little bit in here. I need to work out what this little angle in here is. And to do that, I'm going to have to use this triangle that I've got here at the top. So this is actually a hidden SOHCAHTOA question. Again, that's something that's not come up. I didn't mean to actually rub out all of those, so let me just draw that back in. So I've got my triangle here. Oh, we're not having a very good time here, are we? So we've got a line there. This is the angle I want. This is a right angle, so I want that whole angle there is my final answer. And this is a right angle triangle at the top. So I know that this is 15 meters. Can I work out this little bit here? Well, I know that the whole length is 6, and this length from here to here is 4. So that must be 2 meters there. So I've now got a right angle triangle with 2 sides, and I've got to find an angle. There's only 2 things you can use in a right angle triangle for lengths and sides and angles. That is Pythagoras for lengths, and you can use SOHCAHTOA for length and angles depending on what information that you have. But I'm finding an angle, so I can't be using Pythagoras. It's going to have to be SOHCAHTOA. So they give you these formulas on the front of the exam paper that look like this. So you've got sine x equals O over h, and they are on the formula sheet, equals A, cos x equals A over h, and tan of x equals O over A. So they give you those. So the first thing you have to do in a SOHCAHTOA question is you have to label your sides. Now, a common mistake people make is they label all 3. You only label 2 sides, and they're the 2 sides you're given if you're finding an angle. If you're finding a missing length, you label the side you're given and the side you're trying to find. Don't label all 3. You're going to confuse yourself. You're going to end up using the wrong trig ratio. So I am going to label, this is the angle I'm trying to find here. So if I look at this side here, it's opposite that angle. So opposite the angle is always O. Opposite the right angle is always H, but that side we're not interested in this question. And then the side that's between the angle and the right angle, or next to this angle here, is the adjacent side. Adjacent means next to. So I've got A and O here. So that is telling me that I am using tan of x is O over A. So let's substitute in the information that I've got. So I've got tan of x is the angle. The angle always goes with tan sin and cos. It could also be written as theta, which is the symbol for an angle. So tan of x, tan the angle, equals O over A. Well, I know that O is 2 and I know that A is 15, so I'm going to substitute that in there. So you get a mark for substituting into the formula and showing that you are using tan. Now what you need to remember with any angle question, you're always going to have to use the inverse of tan, because the opposite of tan to get x on its own is tan minus 1. That's the inverse of tan. So whenever you're doing a missing angle, it's always, with trigonometry, it's always going to be tan minus 1, sine minus 1, cos minus 1. Not with sides, only with angles. So you're literally, that's my next mark for using inverse tan, also known as arctan, and you are going to just pop that into your calculator. Again, use the fraction button so you don't get these the wrong way round, because that's really common. To get tan, it's in blue on my calculator. It might be a different colour in yours, but it's above the normal tan button. So we press shift, press tan, and I'm going to use my fraction button so that the 2 goes on the top and the 15 goes on the bottom. Use your right arrow, close the bracket, and then press equals. Now you'll notice here that I have got an answer that doesn't seem right. So if you look here in the top of my calculator, I have got an R. You must make sure that your calculator is in degrees. Do that before your exam, because if your calculator has an R, it's in radians, which is a different measure of angle you won't have learned about yet, unless you've done further maths or A-level maths. So you need to change your angle into degrees. So if you go to, it's not under format, sorry, I've told you the wrong thing there, it's under settings. So if you go to settings and you go to calculator settings, you'll see that there is angle unit. So I need to go back in and change that. See now mine's in radians. So I need to make sure your calculator is in degrees. So then I'm going to go back and I'm going to do my I'm going to press enter again, and you'll see it now gives me an answer that looks more reasonable. So please make sure you check before your exam that your calculator is in degrees, and it has that little D at the top there, and it wants me to give my answer to 1 decimal place. So I'm going to write, because they can't see what has come out of your calculator, so I'm going to write the full display here, and then I'm going to round afterwards. So that's going to be 7.6 to 1 decimal place. However, that's only this little bit in here. I want this whole angle around here, so I need to add the 90 degrees that I already had on there. So my last bit is to do 90, add 7.6. So my final answer for 3 marks is 97.6, and that will get me all 3 marks. And that is it for question 10 for 3 marks. Moving on to question 11. Now this is a similar shapes question. Now I know there was a similar shapes question in paper 1, but this is one of the topics that in multiple years has come up more than once on one different paper, and if it's been lengths in one paper, it'll be areas and volumes in another. Like transformations often comes up on more than one. It hasn't this year. So again, this might not be the case this year, but I thought it was definitely worth going over. So we've got 2 solid shapes here. We can see them, they're in the diagram, and we've been given the radius of A here is 4, and the radius of the circle at the base of B is 8. It also tells me that here, radius 4, radius 8 for the base. And the surface area of A is 80 centimetres squared. So I'm going to write that above A, so I know that's for A there. Work out the surface area of shape B. So with similar shapes, there is a scale factor that links your 2 sides. So they will always be in proportion with one another. So you always start with the lengths if you want to work out the scale factor. So I've got 4 on A goes to a radius of 8 on B. So you need to work out what that's been multiplied by. So this is nice and easy because you've got whole numbers, but if you need to work out what it's been multiplied by, you do the reverse and divide. So it's the larger divided by the smaller. I don't know why I've wrote 2 there. 8 divided by 4 is 2. So my scale factor is 2. So basically, shape B is an enlargement of shape A by scale factor of 2. And because there's not been an enlargement question, it could well be that they put similar shapes in because they are linked. So my scale factor is 2, but however, what you need to know is the length scale factor is 2, but when you do go to surface area, the scale factor doesn't stay as 2 because area is centimetres squared. Remember that is why you need, well, it's not why you need to, but just remember it's centimetres squared, so your scale factor is now squared. Okay, it's not the same, it doesn't just stay as 2. And when you go to volume, the scale factor is, because volume is centimetres cubed, the volume is cubed, okay, because it's 3-dimensional, so the scale factor doesn't stay the same when you're looking at different units. We're looking at centimetres squared and we're looking at centimetres cubed, so that's what you need to remember for any similar shapes question. Find the scale factor, square it for area or surface area, cube the scale factor for volume. So I've been given the surface area of A and I need to work out the surface area of B. So I'm going from the smaller to the bigger, so that means I'm multiplying by the scale factor. If you were going the other way, you would divide by the scale factor, but I'm going this way. So I know the scale factor for area is 2 squared, so I'm not going to times 80 by 2, which is what a lot of people would do. You have to times it by 2 squared. So I'm going to do 80 multiplied by 2 squared, and that is going to give me 320. So you'd get a mark for working out the scale factor or for working out that the scale factor for surface area is 2 squared, and then you get your second mark or both marks for having the answer correct. Okay, now we've been given the volume of B. So the volume of B is 600 centimetres cubed, and that's the volume of B, and I've got to work backwards to find the volume of A. So when we're working backwards with scale factor, we don't times by the scale factor, we divide by the scale factor. So I'm going to do 600 divided by, now when it's volume, my scale factor is now no longer 2, it's 2 cubed. So I divide by 2 cubed, not just 2 on its own. So I'm going to do that on my calculator. 600 divided by 2 cubed, and I'm going to use this button here that allows me to put any power in, and then I'm going to press enter, and that is 75. So a mark for the calculation and 2 marks if the answer is correct, even without your working, but it's always worth showing you're working out, especially on a calculator paper, because nobody can see what you've typed in. So yeah, that's 2 marks each for A and B, and that is a total of 4 marks for question 11. Question 12, we have a direct proportion question. Now I know there was an inverse proportion problem type question on paper 1, but again it's one of those things that quite often the equation type question will come up if they've had a problem solving question on another paper. Because that was inverse, I've gone with direct proportion. So G is directly proportional to the square root of H. So that's the first bit of information I've read, and then it gives you some more information that you're going to have to use. However, the first thing you need to do is to show that. So G is directly proportional to the square root of H. That's the symbol for proportion. You don't actually need to write this bit to get any marks at all. I'm just showing you what the symbol is. So the way we write that is G equals K is the key here, square root H. So if it's directly proportional, K is multiplying the square root of H. If it was inversely proportional, we would have wrote that as K divided by square root of H. So this is inverse here. Okay, but we're not doing that, and this is direct proportion here, and what you're trying to do, K is a constant value that links G and H that I need to find. G and H will change, but K remains constant. So we need to write my equation first, so you normally get a mark for that, writing your equation, so you don't actually need to write this bit here. So you've got a mark there for writing your equation correctly. So now I'm told when G is 18, H is 16, so I can substitute that into here to work out the value of my constant. So G is 18, I don't know K, that's what I'm trying to work out, multiplied by the square root of H, which is the square root of 16. So it says 18 equals Sorry, no, I don't need to do that. Let's give it that. So I need to find k. So I am, instead of timesing by square root 16, k is going to be 18 divided by root 16. Now note here it says the possible values of h. That would suggest to me that there's more than one, and there's a reason for that. And your calculator actually won't tell you this. This is one that you need to know. So if I do the square root of 16 on my calculator, it tells me the answer is 4, but actually there are two answers to the square root of 16. I can have 18 divided by 4, and I could actually have 18 divided by negative 4. So there's two possible values for my constant of k, because when you square root a number you get a positive and a negative answer. Your calculator will only tell you the positive answer, because negative 4 times negative 4 also gives you positive 16. So there's two possible answers here, but I've got a calculator, so I'm going to use that here. So I'm going to do 18 divided by, actually no, let's stick with what I told you before. So use your fraction button. 18 divided by 4 is going to give me 9 over 2, which is 4.5. I'll just show you there. So 4.5 is one possible value, or I can have, this is for my constant, or I can have 18 divided by negative 4, which would be negative 4.5. So you've got two possible answers there. So I've got two possible equations I could have here. I could have g equals 4 square root h, because I now know my constant value, or I could have g equals negative 4 square root h. So you could have either of these. So I've got two possible values then for this last part. Find the possible values of h when g equals 2. So I'm going to do this twice. So g equals 2, I'm going to substitute g as 2, keep my constant as 4. I've got to work out h, and I'm going to do that again with negative 4 here and square root h, and I'm going to get two answers. So they are my possible values. So if I want to get, this is also rearranging equations in here. So if I want to get h on its own, I'm going to first of all divide by 4. So I get 2 divided by 4 equals square root h, and the opposite of square rooting is to square. So h will equal 2 over 4 squared. So you can put that in your calculator. And the other option is, if we rearrange this one, we get 2 over negative 4, and then I'm going to square that. So that's my other possible option for h. So I'm going to pop those in my calculator. So I've got, put the bracket, because it's all, you have to square the whole thing. So I've got 2 over 4, and then I've got, close my bracket, and then I've got squared. So I end up with a quarter if I've got this one here. So h could be a quarter. And then I've got 2, I'm going to go back into my calculator, and I can just use the arrows. I'm going to change that to a negative 4, shift minus gives me negative. But that also gives me a quarter. So in this one, there is actually only one possible answer. And the reason for that is when you square a negative number, you get a positive answer. So actually, there is only one answer. But there could be a case or a question where you might have more than one answer, because it says possible values of h when g equals 2. So h is a quarter, and that would give you 3 marks there. So now we have question 13, and this is a bounds question. I don't know why, but I'm just convinced that this is the type of question that's going to come up. You have already had a very simple, an error interval question, but there has been previous years where when error intervals has come up, there's been a bounds question on a different paper, and it is one that's come up I think it's 4 out of 5 years. So let's have a look at this. By considering bounds, work out the value of f to a suitable degree of accuracy. Give a reason for your answer. So this is what I've been given here. This is my formula, and I've been told that g is 12.7, to 3 significant figures, and H is 9.294, correct to 3 decimal places. So the first thing I would do, and this is what gets you a mark, you're going to write the upper and lower bound of each number, because you get a mark for doing that. Guarantees you a mark. Even if you don't need both, write both of them down. So write your upper and lower bound for each number. So if this has been rounded to 12.7, 3 significant figures, it must have had another significant figure for it to then be rounded. So the way that I do it with decimals, it's not mathematically correct really, but if you look at the number after the decimal as a number, once I've added this 0 on the end, you're going to add 5 and you're going to subtract 5 from this number, and that will give you your upper and lower bound. So 75 and 65. So it's going to be 12.75 and 12.65, because that would have been 4 significant figures then rounded to 3. So now if I do H, I have got the same thing. I've got 3 decimal places, therefore it must have had 4 decimal places. I'm just going to pop a 0 on the end there. So now if I just look at this number here after the decimal, 2,940, and I add 5 and I take 5, I'm going to get 2940 add 5 is 2945, and 2940 take 5 is 2935. So that gets you a mark there for having your bounds correct. Now I've got to work out the value of f. Now because I'm doing it to a suitable degree of accuracy, it doesn't say upper or lower bound. You have to do both the upper and the lower bound. So I'm going to do the upper bound of f and the lower bound of f. So to get the upper bound of f, you've got to do the square root of g over h, and to get the upper bound you want the biggest possible answer you can get. So if you want the biggest possible answer that you can get, you want the biggest possible answer on the top. So that's the upper bound on the top, and divide by the smallest possible answer on the bottom. That's what's going to get you the biggest answer. Biggest number divided by smallest number is going to get you the biggest answer. So I'm going to do the square root of the upper bound of g. So the upper bound of g is 12.75. Division, people often get the upper and lower bounds wrong. And the lower bound of, I want the lower bound of h, so that is going to be 9.2935. So I'm going to pop that in on my calculator. Make sure the square root is only on the top. So I press fraction first, then square root, then 12.75, down arrow, and then 9.2935. And then I press equals. You want to keep this answer. In fact, if you can, I would write the whole thing down. I'm going to see how much I can squeeze on this bit of the page here. 163. Oh, I've done the whole thing. I've fitted it on. Right, there we go. So now let's do the lower bound as well. Notice I'm showing all of my working out, even though I'm doing it on a calculator. So again, this is going to be square root of g over h, but this time I want the smallest possible answer. So I need the smallest possible number on the top divided by the biggest possible number on the bottom. It's the reverse of the upper bound. So now I want the lower bound of g, or the lower bound of g is, so I'm actually using all of these here. The lower bound of g is 12.65. Don't forget the square root. And then the upper bound of h, so the upper bound of h is 9.2945. So I'm going to work that out on my calculator. So fraction button, square root button, 12.65, down arrow, 9.2945 equals, and then again I'm going to see if I can squeeze that whole answer in here. 382665431. So that's it. That's my 2 answers. Now I have to give it to a suitable degree of accuracy. So what that means, I'm going to round it to as many decimal places as I can where these two both still give me the same answer. So always start at the beginning. If I round to the nearest whole number, what will they round to? They will both round to 0. So I could do that, but let's go one more. If I round them to 1 decimal place, what would they both round to the same thing? Yes, they would both round to 0. So this is the upper bound, and Oh, I don't know what I've done there. That's the W. So this is the upper bound and this is the lower bound. If I rounded them to one decimal place, they would both round to 0.4. So let's see if I go to two decimal places. Do they both round to 0.38? Yes, they do. So I can keep going. So this is a better degree of accuracy. It's more accurate because I'm giving more decimal places, you see. So this would still be suitable as they would both round to the same thing. Then I go to the next number along. Now this would round to the upper bound would round to 0.384, whereas the lower bound would round to 0.383. So we can't use that because that is not a suitable degree of accuracy. So the best answer that I can give, my suitable degree of accuracy, is two decimal places, as both round to the same as far as two decimal places. So that is how you do your bounds question, but that often catches people out, that suitable degree of accuracy, but you have to keep going as far as you can where they both give you the same rounded answer. So you'd get a mark for your bounds, you'd get a mark for each of these being correct, you'd then get a mark for your answer and then your explanation there as well. So that is question 13 for 5 marks. Question 14, I've got to make x the subject of the formula. Hasn't come up yet. It isn't on the exam every year, although I've just got a feeling it's going to be on there, but again, I could be wrong. And I think they might put a trick. I haven't seen a tricky one for a few years. So yeah, I've got a over b equals 2x over x plus 5, and I've got to make x the subject. So the issue I've got here is you've got x twice, but the first thing I can see here is I've got two fractions, and I need to get rid of the fraction first to be able to do anything. To make x the subject, you don't want any fractions in there. So if you've got fractions on both sides of an equation, you can do what's called cross multiply, and it gets rid of the fraction. And if you don't have a fraction, so say for example you just had a, you can put a over 1 and it makes it a fraction, so you can still use this. So when you're cross multiplying, you're going to times this by this, and then you're going to times this by that, and it eliminates the fraction. So let's do the left hand side first because that's what I'm starting with. So a times by all of this. In fact, I'm just going to write it like this to begin with, and then I'm doing 2x times b on the right hand side, so 2x brackets b, and that's eliminated my fraction. So that's what I've got first. So I'm going to expand my bracket here. So a multiplied by x and a multiplied by 5, I get ax plus 5a, and then that equals 2bx or 2xb. It doesn't matter which order you put it in. So now, because I need to make x a subject, I need to get the x's together. So you want the x's on the same side, and anything that doesn't involve x on the opposite side. So it doesn't matter which side you rearrange to, both answers will be correct. So I'm going to minus the 5a first of all from both sides. So that gives me ax equals, I've got rid of 5a here, and I end up with 2bx minus 5a on the right. But now, because I want the x's together, I'm going to minus 2bx from both sides. Now you can't do ax minus 2bx, so you just write, I'm going to move up here, ax minus 2bx, you just write it like that, equals negative 5a. And now, the problem I have here is I cannot add or subtract these together because they're not like terms. This is ax, this is 2bx. So this is quite common if you get a change the subject question or make x the subject of the formula, or any letter for that matter, and you can't work out what to do here. The key is to factorise, because that's the only way that you can get x out on its own. So if I take x out here and put it on the outside of the bracket, what I'm left with is a minus 2b inside the bracket, and then I've got my negative 5a over here. So then I can get rid of this whole bracket because it's multiplying, and the opposite of multiplying by a bracket is to divide by that bracket, and always write it with algebra, divide as a fraction. Okay, so I'm dividing both sides. That then cancels that out. That leaves me with x, which is what I want as the subject, negative 5a over a minus 2b. And that is the answer. That's not a very good arrow, but you get the idea. That is the answer that I would put here for 3 marks. So you'd get a mark for here for cross multiplying and getting rid of your fraction. You'd then get a mark for, I'd imagine, for either isolating x or for factorising, and then the last mark for the answer. There is an alternative to that if you've rearranged to the opposite side. Both answers are correct as long as you've rearranged it correctly. So that is question 14 for 3 marks. Moving on to question 15, not too far away from the end now. So I have been asked to work out the area of the triangle to 1 decimal place. So this triangle here, you can't, if you think about area of a triangle, you probably think of base times height divided by 2. Well, we can't use that because we don't have the base or the height. The other rule that you can use, which is on your formula sheet for the area of a triangle, is half AB sine C. And what you need for that is the 2 sides with the angle in between them, because this will be your angle C and these will be your sides A and B. At the moment, we don't have that, which is why this is worth 5 marks, because we've got a couple of steps that we're going to need to take to get there. So it's a non-right angled triangle, so that tells me I'm either going to be using sine or cosine. These formulas are given every year. This has come up, and mainly on paper 3. It's not been on there yet, so I'd be very surprised if it's not there, but again, I can't make any guarantees, and it could be that this year they decide to change it up and it's not on there at all. But they do. I've seen several times in the past it is mixed with area of a triangle as well. So we'll see what they decide to do this year. So what I need is, I've got this side here, so I need to find, I've only got one side, I need another side. So the key is, if you are using cosine, it will be anything with 3 sides involved. So that means you've got 3 sides and you're finding an angle. Well, that's not the case here, we want another side. Or you've got 2 sides and you are finding the 3rd side. Well, that's not the case either, because I've only got one side. So that means I can scrap out using cosine. Okay, it's not going to be cosine, it's going to be sine. Now, to use sine rule, you have to be able to make a cross in your triangle so you have angle opposite side, angle opposite side. These letters can be the other way around, but they have to have 2 angles, 2 sides with 1 piece of information missing. So if I look here, I can do that with my 40 and my 12. I've got those 2 there. So I now can find this side over here. Whatever I'm going to need to do, I'm going to need to find my other angle, because if I find, let's say I find this side over here, if I'm using half AB sine C, I need 2 sides with the angle that's in between them, so I would need to work out this angle anyway, because that would be between the 2 sides that I then have. So we can either do that now or we can do that afterwards. Let's work out x first. So sine rule is given to you on the formula sheet like this: A over sine A equals B over sine B, and then it's got C over sine C. You don't need that part. Okay, we're only working in 2D, so you only need this part of the formula. If you're working out an angle, you can flip this formula up the other way, and it's use it in exactly the same way. So you'd have sine A on top and sine B on top. These little letters are for sides. These big letters are for angles. Okay, so that's important. So, and these 2, little a and big A, have to be opposite each other, and little b and big B have to be opposite each other. So they give you the formula, so all you need to know is understand that and be able to substitute the values in. So let's say my little a is x. Ignore, it doesn't matter, because I don't have to use the letters that are on my triangle. They don't apply to my formula, so just ignore those, okay? Just remember they have to be opposite each other. So let's say x is my little a. The angle opposite that is 82, so it would have to be sine of 82 there, and that is equal to b, which is the other side that I've got, which is 12, and then I've got, that's opposite angle of 40, so sine 40. Okay, so that is a mark there because I've identified sine and I've substituted the information in. I would then get another mark for working that out. So in order to work that out, I'm going to times by sine 82, so that it just leaves x on its own. So I get 12 times by sine 82 over sine 40, and then I just work that out in my calculator. Remember what I said earlier though, make sure your calculator is in degrees, which it is now thankfully. So I'm going to type that in, and you want to make sure you also, if you put sine 82 first, you make sure you close the bracket, and then I would always just do that just in case. So sine 40 on the bottom, close bracket, and I've typed it in exactly as it appears. So that tells me that it is 18 point, and I'm going to leave it to a few decimal places for now. You don't want to round until right at the end. So that is this side here. This side here is 18.487. So now if I'm going to use sine rule, bearing in mind what I said here, you need two sides with the angle in between. Again, the letters aren't really important apart from determining which go where. You don't need to, just because this was A in this formula, it doesn't have to be A in my other formula. I've got this side and I've got this side, so I need the angle between them. Well, I should know that angles in a triangle add up to 180. So 180 minus 82 plus 40. And again, simple, but just do it on your calculator. Why not? You've got it there. Make sure you use it. So I'm going to do 182 minus... 82 plus 40, subtract that from 180, and I get that this angle here is 58. Notice I'm also writing on the diagram. That's a good idea to do, good practice, in case you get your labelling wrong, so that they know which angle or side you're talking about. So I now have all the information I need to use the area of my triangle formula. I've got two sides and I've got the angle in between them. So I literally just plug those values in now. So my two sides are, now here is where you could use, you can't use the answer button actually, because I've already got 58, so it would put 58 in. So I'm going to have to use this. Times by 18.487, that's A or B, doesn't matter, times by the other side that I've got, which is 12, times by sine of the angle I have between them, which we've just worked out, is 58. So I literally just type that into my calculator. So I've got half or 0.5, you can use either, they're the same, 18.487 times by 12 times by sine, there it is, of 58, close bracket, enter, and there is my answer. Again, I would write the fully unrounded answer before you round on your answer line, just in case, just so you make sure you're not losing any marks in case your answer is incorrect. You show all of your working. So my answer to one decimal place will round to here, so that'd be 94.1 meters squared for 5 marks. So I'd imagine you'd have got 2 marks for getting up to 18.47, another mark for working out the missing angle, then for substituting into the formula, and then for having the correct answer rounded correctly to 1 decimal place. So that is 5 marks for question 15. I would highly recommend going over sine and cosine if that's something that you're not confident with, because you get given the formulas, you just need to know how to use them. So we are now on question 16. Kira bakes vanilla and lemon cupcakes for a party. There are 5 more vanilla than lemon. Kira is going to pick 2 cupcakes at random. The probability she picks 2 of the same flavour is a half. Work out how many cupcakes Kira baked. So this is a probability question with algebra, and the reason I know it's with algebra because you're not actually told the number of cupcakes, but you are told there are 5 more vanilla than lemon. So let's say we call lemon X because we don't know how many lemon cakes there are. Then the vanilla will be X add 5 because there are 5 more vanilla than there are lemon. So we've got X for lemon and X plus 5 for vanilla. Now you could draw a tree here, but you're going to end up probably running out of space. So we want 2 cupcakes of the same flavour. Well, she can have vanilla, vanilla, or she can have lemon, lemon. They're the 2 cupcakes of the same flavour. So the probability that I pick a vanilla to begin with for my first one, I'm going to need the total, because probability has to go over the total. So I'm just going to add these 2 here together, and that gives me my total, which will be my denominator for my probability. So that's going to be 2x add 5. So that's going to be is going to be out of 2x add 5, and the probability that I pick a vanilla, well, this is my expression for vanilla, so that's what goes on the top. Then I want a vanilla again, so I'm going to multiply because I want the next one to be vanilla as well. But because it says she picks 2 cupcakes at random and doesn't say she puts anything back, we have to assume it's not been replaced. That is conditional probability, which affects the denominator here because she hasn't replaced the cupcake. Therefore, there is one less when she goes to pick the next one. So it's going to be 2x add 4, which is one less because I picked a vanilla the first time. So there's one less cupcake. And if I picked a vanilla the first time, the number of vanillas will have also gone down. So instead of being plus 5, it's going to be plus 4. So that is the probability there of getting vanilla, vanilla. So now I'm going to do lemon, lemon. The denominators here will be exactly the same because that's the original total, 2x plus 5. And then when I've picked a cupcake, my denominator is going to go down to 2x plus 4. So that denominator, those denominators there will be exactly the same as we've got here. Then you are looking at lemon now. So the probability she picks a lemon to begin with is x. Once she's taken a lemon, the probability of a lemon is going to reduce by 1. So that'll be x minus 1 because there's one less lemon cake when she goes to take the second. So that's lemon, lemon. And if I can have either of these options, I would add those options together. And I'm already told the answer here. That equals a half. So that's how you set it out, and this is now what we've got to try and work out. So let's simplify these fractions. When I add these together, we know the denominator is going to remain the same because they've both got the same denominators here. So I'm just going to write this as one, otherwise I'm going to run out of space, as one whole denominator. And I am going to multiply it out. So let's do it here. So I've got 2x times 2x is 4x squared. Then I've got 2x times 4 is 8x. And then 5 times 2x is 10x. So that's going to give me 18x, and then 5 multiplied by 4 is going to give me 20. So that is my common denominator that I'm going to get when I add them together, because if the denominators are the same when you're adding, then it stays the same. So this and this are the same. So now let's work out the top. So I'm going to have to multiply these as well. So it's like having a double bracket. So I'm going to do x times x, which is x squared, and then x times 4 is 4x, x times 5 is 5x. If we add those together, we get 9x, and then 5 times 4 is 20. I'm going to need to go along a little bit here. And now I'm going to do the numerator, here. So I've got to do x multiplied by x, which is x squared, and x multiplied by -1, which is negative x. And we know that that is all equal to a half. So what I've done there is I've expanded the bracket and added my two fractions together, just as I would do normally with normal fractions. You add them together, the denominator stays the same, and you add the numerators. And I've just written it all here as one fraction to save on space. So now I'm going to simplify the top here. So I've got x squared and I've got another x squared. So therefore I've got 2x squared. And I've got 9x take 1x, so that's 8x. And then I've got just plus 20. So that's me simplifying the top. And then at the bottom, I've still got 4x squared, add 18x, add 20, and that is all equal to 1/2. So here, because I've got fractions on both sides, to get rid of the fraction so that I can solve this, I can cross multiply. So I'm going to times that by 2, and I'm going to times the 1 by this here on the bottom, and that will get rid of my fraction. So all of this multiplied by 2 is going to give me 4x squared plus 16x plus 40. I'm going to run out of space there actually, so what I'm going to do is I'm going to get rid of that and I'm going to do it below. So I'm going to run out of room. So all of this multiplied by 2 is 4x squared, add 16x, add 40. And that is equal to one lot of this denominator here, which just means it's going to stay the same. So 4x squared, add 18x, add 20. So now I've got to solve it. Well, it's I've got to work out, if it's a quadratic, I've got to make it equal to 0. However, because I've got 4x squared on both sides, I can just minus 4x squared and it cancels those out. So I'm actually left with 16x add 40 equals 18x add 20. So that's just a solving equation question. So if I've got x's on both sides, what I want to do is get rid of the smallest x. So I'm going to subtract 16x. And if I subtract it from the left, I have to subtract it from the right, which gives me 40 equals 18x take 16x is 2x plus 20. Okay, and now when I'm solving this, I'm going to I'm not going to add 20, I'm going to subtract 20 because I want to get x by itself. Subtract 20, which gives me 20 equals 2x. So therefore, if 2 lots of x is 20, 1 lot of x must be 10. However, that's not quite finished. That gives me x. I've been asked for how many cupcakes Kira baked in total. So if I know that lemon is 10, I've now got to work out what vanilla is. Well, it's x plus 5. So that's just going to be 10 plus 5, which is 15. So my total is these two added together, which is going to be 25. And that is my final answer there for 6 marks. So you would get a mark for one of these, this expression up here, I would imagine. Then you would get a mark for working out either vanilla or lemon. If you've got both of them, that would be another mark, so that would be 3. You'd get a 4th mark for having it as an equation. And then you'd get a mark for simplifying it down here, and then you'd get a mark for having your final answer. So that's why it's worth 6 marks. There's quite a lot of working out there. Question 17. We have got to prove that the sum of the squares of 2 consecutive integers is always an odd number. So this is an algebraic proof question. There was a proof question in question 1, but it was with circle theorems, and they quite like to put these algebraic proof questions in, which is why I've added it in here. So if I'm going to prove it, you can't do it numerically. You have to do it with algebra. So a lot of people try and do this by showing some examples. You won't get any marks for that. If you're asked to prove it, you need to do it with algebra. So, first of all, you need to know how you're going to write 2 consecutive integers. Integers are just whole numbers. So for any number, you could just use n. That could represent any number at all, or you could use x, whatever letter. Don't mind what letter you use. So I'm going to go with n. The next number after n, so if n was 5 and I wanted to represent 6, I would just have to add 1 to get to the next number. So when you're talking about consecutive numbers, you use n and n plus 1, or x and x plus 1. Just as a side note, not to do with this question, if you want to represent an even number, they like you to use 2m. The next even number after that would be 2n plus 2. If you wanted an odd number, well, that's going to be an even number plus 1, because after an even number, you get an odd number. So this is even. Just for giving you these in case it comes up, this is next even number. Next even number. This is odd. The next odd number, so the consecutive odd number would be 2n plus 3. That's the next odd. So they're useful to know if you get a question like this, because that's what you're expected to start with. But anyway, back to what we're doing. So we've got 2 consecutive integers. So an integer n, the next integer along, the next number along is n plus 1. So I'm going to do the sum of the squares of these numbers. So I'm going to have to square them both. So n squared and then n plus 1 all squared. You're squaring the whole thing. And sum means I'm adding them together. So that's what I've got to do, and I've got to simplify and expand this. So n squared plus, now if you've got n plus 1 squared, it means you've got n plus 1, n plus 1. So we're going to then have to expand that bracket. So I've got n squared plus n squared. N multiplied by 1 is 1n. N multiplied by 1 is 1n. You can just write n, and 1 times 1 is 1. So now if I simplify that, I've got 2n squareds So 2n squared. I've got 1n add 1n, which is 2n, and I've got plus 1. So that would get me up to 2 marks. So you'd get a mark for writing these, or writing, I'd imagine your first mark actually would be for having this correct. And then for getting to this stage here, you would have your second mark. But I've got to prove that this is always an odd number. So if you think about odd, what we said earlier here, an odd number you have to show that it's even and you're adding 1. That proves that something's odd. Well, if we look at this here, I can prove that this is even by factorising just this part here. If I take the 2 out and I put n squared add n there, if you multiply any number by 2, it's going to be even. It's therefore a multiple of 2, and it's in the 2 times table. So this is an even number here, and if I add 1 to it, that proves that it's going to be an odd number. So the proof at the end is the factorising. So you often have to factorise at the end to complete your proof question. So there's lots of different types of these questions. You can find them online and do them on Maths Genie is quite good. It's got lots of proof questions and Corbett Maths. But if you practice those, it's always similar ones that come up. So that is 3 marks for question 17. Question 18, we have a quadratic sequence. Now there has been sequences, linear sequences in paper 1, but that won't stop them putting a quadratic sequence in there as well. And it is something that they like to put in the calculator papers. So I have a quadratic sequence. So the first thing that I need to do, and I'm just going to write the numbers out here so it's easier for me to work with, is to work out the differences between the numbers. So that's going to be 1, 2, 3 and 4. That's what makes it a quadratic sequence, not linear, because the differences here are not the same. So I now have to find the second difference, the second set of differences, and on a quadratic sequence these should be the same. The difference between 1 and 2 is 1, 2 and 3 is 1, and 3 and 4 is 1. So that tells me I've done that correctly because the second differences are the same. Now there's a couple of ways of doing this. Some people like to do it with the table. I like the algebra method, so I'm going to show you my way. If you don't like that and want me to show you the other way, then please let me know and I can always record that for you. So I have got these numbers here. These are the only 3 numbers that I'm going to use to work this out. Okay, and there's 3 things that you need to remember for this. The bottom number is always equal to 2a, the middle number is always equal to 3a plus b, and the top number is always equal to a plus b plus c. So you do have to remember these 3 and remember to use those 3 numbers, but then it's quite simple after that. You also need to know the general expression for a quadratic sequence is an squared plus bn plus c. Okay, similar to a quadratic when you'd have ax squared plus bx plus c, because it's a quadratic sequence, they just use n instead of x. So let's use this. You always start with the bottom row here. So I've got 2a is equal to 1. Well, therefore a I divide by 2 is a half. Okay, so I've worked out what a is here, and that's going to go into my sequence. So I know that's going to be a half n squared there, so I can write that down already. So you get a mark for finding the second differences. You'd now have another mark, 2 marks for having a half n squared, because you've identified that it's a half n squared. You then use this with the next row. So I'm going to go up next and I'm going to use that there. So I've got 3a plus b is equal to 1. However, I already know that a is a half, so I can do 3 lots of a half here, because I already know that a is a half, plus b equals 1. Well, 3 lots of a half, half of 3 is 1.5, plus b equals 1. Well, I subtract the 1.5, 1 take away 1.5 is going to be negative 0.5, or you can put negative a half, so that you keep the same format, but it doesn't matter. So I now know that b is negative a half. So I know it says plus b, but because it's negative, we write negative a half, because when you add a negative, you're still subtracting. So that quite often catches people out. They think because it's a plus, that it has to be positive in their answer. It doesn't. So that's minus half n. Now I've just got to work out c. So I'm going to use this last row here. A plus b plus c is equal to negative 2. And I know that a is a half. I know that b is minus a half. Or negative a half, sorry. And then I've got to find out what c is. Well, half take away half is 0. So it just leaves me with c is negative 2. So then that's going to be the last part of my expression here. And that is it. That is my final answer. So a half n squared minus a half n minus 2. And that is my final answer for 4 marks. So you'd get a mark for finding the second differences, a mark for having this correct, a mark for having this correct, and then a mark for having this correct. So that's where your 4 marks would come from. Question 19, nearly at the end, and it's very common for them to put a volume or surface area question of this nature in there. The only difference with this question is it's got pi in the answer, which would normally be on a non-calculator paper. However, they do sometimes throw it in on a calculator paper so that you have to work it out yourself algebraically without using your calculator. Just because it's a calculator paper, it doesn't mean you're going to need that for every single question. They still like to test you on non-calculator skills. So we've got this information here. The height of the cone is 10 centimetres. Well, I can see that. It's already on the diagram. The base of the cone has a diameter of 6. Well, again, I can see that. It's already on the diagram. The hemisphere has a diameter of 6. So all this information here is just telling me what I can see on the diagram. The total volume of the shape, so I'm finding the total volume, is k pi centimetres cubed. So you're going to have to leave pi in. You're not going to be using your calculator for this question. And it says k is an integer. That's a whole number. Work out the value of k. So if I'm going to do the total volume, I'm going to do the volume of each, the cone and the hemisphere, volume of cone, and then I'm going to do the hemisphere, and then to get the total I'm going to add them together. So the volume of a cone is given to me. They give you that formula there. So that's a third times by pi times by the radius. Now you're given the diameter, so the radius is half of that, which is 3. So be careful there because that catches people out. And the height of the cone is given here, and it's also told to me here is 10. So you get a mark for that substitution there. Now I'm going to simplify this, but I'm timesing, so I'm going to put all of these over 1. So I times the numerators and then I times the denominators. So I'm going to have 1 times 3 times 10, which is 30, and I'm leaving pi, remember, in there because it wants pi in the answer. And then 3 times 1 times 1 times 1 is just 3. And then 30 pi divided by 3 is just going to be 10 pi. So that is my volume of my cone in terms of pi. Now I'm going to do that with the sphere, but it's not a sphere, it's a hemisphere. So this gives me the volume of a sphere. I've only got half a sphere, so I'm going to have to do 4/3 times pi r cubed, and then I want half of my answer, so I times it by half. Of means multiply, remember. So volume of H sphere, that means hemisphere. Okay, so I'm going to do 4/3 times by pi times by my radius, which remember is 3, and this time it's 3 cubed. Make sure you read the formula. Times by the a half, which equals, right, I've just realised actually I have made a mistake because I didn't square my radius. It was pi times radius squared times 10. So be careful and make sure you don't do what I've done. So you actually get 90 pi over 3. So when you divide 90 by 3 you get 30 pi. So make sure you don't make silly mistakes like that in your exam. Okay, so let's go back to the volume of the hemisphere. I'm going to put these over 1. So I've got, this is where you could use your calculator to check here. So I've got 3 cubed, which is 27, and I've got to times that by 4. But if you do that on your calculator, it gives you 108, and then you leave pi in there. And then I've got 3 times 1 times 1 times 2, which is 6. And then again, you might want to do 108 divided by 6 on your calculator to check that you've got the right answer, but it's 18 pi. You get there. 108 divided by 6 is 18 pi remains in the answer. Now I want the total volume, so I'm going to write total down here, and that is 30 pi plus 18 pi. So that is going to be 48 pi. Now don't write that as my answer because it only wants k, and k is the value that is in front of pi. So my answer is going to be 48. So if you've got 48, you can give yourself all 4 marks. If not, you get a mark for here, you get a mark for here, you'd get a mark for adding them together, and then 4th mark for your answer. So that is question 19 for 4 marks. Question 20, the second to last question, and you have got ratio. There's bound to be something on ratio. It's normally in every paper. So I thought this was quite a nice question because lots of people get confused and don't know how to answer questions like this. So I've got x squared to 5x minus 24 is equal to 4 to 1. So I can write this as x squared over 5x minus 24 is equal to 4 over 1. Okay, nice trick there. So if you've got 2 equivalent ratios like this, you can write them as fractions and equal them to each other. And that's going to help us answer this question and find the possible values of x. So we've seen this already in my walkthrough. If you've looked at some of the other questions, because you've got fractions here and you're solving, you can just cross multiply. So you're going to do x squared multiplied by 1, which is just x squared. And then you're going to do 4 multiplied by 5x minus 24. Well, 4 lots of 5x is 20x, and 4 lots of 24 is, again, you can check that on your calculator, is 96. Okay, so that's got rid of my fraction by cross multiplying, and now we can see I've got a quadratic here, so I'm going to want to make this equal to 0. So I'm going to subtract 20x and add 96 on both sides, and that will make it equal to 0. So I end up with x squared, I didn't put x there, but minus 20x, add 96 equals 0. Now, you've got quite large numbers here, and it is a calculator paper. So I would suggest if you get something like that, I would use the quadratic formula, and they give you this on the exam paper, and it looks like this. It's on the front of the exam paper. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you've got large numbers, it may not factorise anyway, but you'd be there a while probably trying to find the factors of 96 that add to give you negative 20. And in this instance, when you get to the answer, you'll see it's a decimal, so that it wouldn't have factorised anyway. But large numbers, even if you can factorise, I would recommend using the quadratic formula on a calculator paper. One simple tip: every time you swap a letter for a number, put it in a bracket, and that will ensure you don't make any mistakes by missing signs, or the calculator won't work it out correctly for you if you've got negatives and you don't use those brackets. So first of all, I'm going to write down the values of a, b and c, and then I'm going to substitute them into my formula. So this is a quadratic expression: ax squared plus bx plus c. So a is the value in front of x squared. Well, I don't have one, so that would be 1. And b is the value in front of x, so you've got to make sure you include the sign. It's going to be negative 20. And c is the value at the end, which is just 96. So now I can plug those values, and you're going to put it in your calculator, but I would also plug them in on your, as part of your working out, just in case you make an error with your calculator. So minus, I'm substituting in, I'm swapping b in, so I'm putting a bracket here and I'm putting negative 20, because people often forget to have a double, to have a subtraction and a negative here. That's why it helps to have the brackets as well. Plus or minus the square root, and again put a bracket. B is negative 20. If you don't do that, you'll get the wrong answer on your calculator, because it will only square the 20 and not account for the negative. Minus 4 multiplied by a, which is 1, multiplied by c, which is 96. And then you're going to put it all over 2 lots of A, and that's going to be 2 lots of 1. So this here, when I put this in my calculator, will give me 2 answers, because I'll do it once with a positive and then again with a negative. So I'll get x equals and x equals. So now I'm going to need my calculator for this question. I'll put that to the wrong side there. So my calculator, I have got to put my fraction button in, and then I'm going to put minus negative 20. You can just use the regular minus button. I'm going to do plus first. The square root of negative 20 squared minus 4 times 1 times 96. And then I'm going to go down and I'm going to do 2 times 1. I don't really need the bracket there because I know what 2 times 1 is. So that gives me my first answer for x, which is 12. And then if I go back, I don't have to type this all in again. I'm just going to go back in my formula here, and I'm going to go back and change this to a negative. And that is 8. I must have done it wrong when I practiced it earlier because I got a decimal answer. So that this could have been factorised. You could have done it by factorising. However, they're large numbers, so I would recommend using the quadratic formula here. So they're your 2 answers, x equals 12 and x equals 8. So that is it for question 20. So you'd have got a mark here for cross multiply and get rid of your fractions. Another mark here for equaling it to 0, a mark for either factorising or substituting into the quadratic formula, whichever method you used, and then the final mark if you had both of your solutions correct. So that's where your marks would come from. Okay, so question 21, our final question, and it is equation of a circle. This has come up every year, and it hasn't been on paper 1 or 2, so it's highly likely to be there. I can't guarantee it, but it is highly likely to be on there. So you should know that the general equation of a circle is x squared add y squared equals r squared. And if you have a circle in this format, the coordinates, asking you here for the coordinates of the centre will always be 0, 0. If it's written x squared plus y squared and doesn't have anything else here, then the centre will always be 0, 0. You've then been asked to write down, this is key here, the exact length of the radius. Well, if you look here, it's x squared plus y squared is r squared. So we know that r squared is equal to 5. So therefore r, my radius, will be the square root of 5. You don't put that in your calculator and work out the decimal answer, because that would not be exact, because you would be rounding. You literally put square root of 5 as your exact answer. So that's why 1 mark there and 1 mark there. So that's just knowing the basics about the equation of a circle. Now this here, I would always draw yourself a diagram. It helps to have a sketch. I've got my circle. I know that my centre is 0, 0. And I'm told P is the 0.12 on the circle. So let's say P's here, and that's 0.12. And I've got to work out the equation of the tangent. So the tangent at P, so this is P here, would be a line like that. That would be my tangent. Okay, so it's a line that touches the edge of the circle. It's not very straight, but you get the idea. So in order to do the equation, that's a straight line. Equation of a straight line is in the form of y equals mx plus c. And to do the equation of a straight line, you always need the gradient and you need a coordinate that lies on the line. Well, I already have a coordinate that lies on the line because P lies on the tangent. So I already have an x and a y coordinate that lies on my line. So now the only piece of information I'm missing is the gradient. In order to get the gradient of this, you should know that a tangent to a circle is perpendicular to its radius. So if I draw the radius in there, that is a 90-degree angle. So if I work out the gradient of the radius, which I can do because I've got the centre and the 0.12, I can work out the gradient of the radius. this gradient here that I'm looking for my tangent will be the perpendicular gradient. So the formula for gradient, which they don't give you, is y2 minus y1. That's just the difference between your y coordinates over x2 minus x1, which is the difference in your x coordinates. So I'm going to start with my y coordinates, which are 2 and 0, and I'm going to subtract this way, which means I need to go the same way with my x coordinates. So I'm going to do 2 subtract 0, and then here, same way, I'm going to do 1 subtract 0. So therefore my gradient is 2 over 1, which is 2. So that's the gradient of my radius. If I want to get the perpendicular gradient to this, it's the negative reciprocal, and the negative reciprocal of 2 is negative 1/2, because the reciprocal of 2 is a half, the negative reciprocal is negative a half. Which makes sense, because if this has got a positive gradient here, this is going to have a negative gradient because it's coming down. So I now have all the information I need to be able to write the equation on my line. I'm just going to substitute m, x and y into y equals mx plus c, and that will enable me to find out what my c value is. So y is 2, so I'm going to write 2 equals, m is negative a half, so I'm going to write negative a half, x is 1, and then I'm trying to work out what plus c is. So now I'm going to end up with 2 equals negative a half times 1 is just negative a half, so 2 equals negative a half plus c, and then I add the half to get c, so c is going to be 2.5. So now I can write my equation, because to write your equation, when you write an equation on the line, y and x stay in there, m and c remain constant, so you substitute those values in. So you end up with y equals, well, we know my gradient was negative a half, so negative a half x, and my c value is 2.5, so plus 2.5, and that will get me 4 marks there. And that is it. That is the end of the paper. So I hope that's been helpful. If you've got any questions or anything else that you'd like me to record a video on that you'd find that would be helpful, please let me know in the comments and I'm happy to help. But good luck with your final paper on Wednesday. I'm sure it's going to be fantastic, and then you're nearly done. So yeah, thanks for watching my walkthrough. Give us a like and subscribe if you found that helpful. And come back for more help and support if you need it. Good luck, guys.